Today's tutorial topic is electronics. We will pick one segment and we'll talk about it. The segment will be vacuum triode. It is a continuation. We have in our previous tutorial talked about plate characteristic of vacuum diode. So it is completely done and we will do it for triode now. So let me talk about a little bit of backstory I'll give you. So in the year 1906, Dr. Lee De Forest, who was actually an American scientist, placed, so let me reduce a little bit the inside, placed a third electrode in the form of wire mesh between cathode and plate of vacuum. So plate of vacuum diode. The resulting device was called a triode. So important this discovery is that it ushers in the electronic industry really as we know it today, or really as we know it today. So it is a thermionic valve containing 3 electrodes. These are namely cathode. This is the first one. Second is grid. And the third one is anode. Now for effective control of electrons, the grid is kept closer to the cathode than the plate, and our plate is nothing but the anode. So application of triode valve, so I'll write then. So this is the applications. So this triode valve can be used as number 1, amplifier, number 2, oscillator, number 3, detector or modulator, and lastly is the transmitter. I've written Roman 4, but it should be just 4. Okay. Now we'll talk about the construction of a triode valve. So next we will talk about the construction of a triode valve. Now as the name suggests, a triode has 3 electrodes, which we have just said. They are namely cathode, grid, plate and control grid. Okay. The cathode is located at the center of the tube and is surrounded by control grid, and which is in turn surrounded by plate. So as you can see in the diagram, this is how it looks like. This is the cut away view and this is the symbol. Okay. So the cathode and plate actually, so let me write it down. The cathode and plate have similar construction as for a diode. Okay, now the control grid represented by G consists of a fine wire mesh that is placed very close to the cathode. The spacing between the turns of the mesh are wide enough so that passage of electrons from cathode to plate, is not obstructed by the grid. Moreover, the electrons attracted to the plate from the cathode actually go through the openings in the grid. So this, as I've said, is the cutaway view of the triode, whereas this shows its symbol. The dotted line between the plates, this one, and the cathode is in the symbol represents the control grid. Next we move on and we will talk about the working of the control grid. Now for this purpose we need to draw a diagram. So first let me clear the page and let me draw one diagram. So here what I'm gonna do is that I'll make 4 diagrams. They will be different from each other to a very small, means the difference will not be huge. So these are my 4 diagrams, and these I'll just mark it. So like this. In the previous diagrams I have made the circuit, battery, entire thing, how you will give the current. The entire circuit has been drawn, but here you don't need to. Just this will be sufficient. And as I've already said that, if you remember anything, if diagrams are added to any particular tutorial, it makes it. So I have already done with the construction. So we'll start with the working. I have already drawn the figures. So we will actually concentrate on the working of the control grid. So let's get started. Now the electrons emitted by the cathode actually pass through the opening of control grid to reach the plate. Now as the control grid is closer to the cathode than the plate, therefore what happens is that a small voltage on the control grid has much more control, so has much more control on the electron flow than a comparatively high voltage on the plate. Now this places the control grid in a actually commanding position to control the plate current flowing in the triode. Now this figure, let me mark it as A, B, C and D, and let me change the color. Okay. Now the figure shows the action of control grid in a triode at different grid voltage, assuming the plate potential remain constant. So first we'll talk about A. Now when the control grid is at zero potential with respect to the cathode, so referring to figure A actually, the triode valve just behave like a diode. So there is no difference actually. This is not surprising since under these conditions the presence of control grid does not affect or does not have any effect on the electric field actually, that is between the plate and the cathode. Now we move on to the part B. So I'll write here only because so that it's easier for reference, easier to refer the, and I remove this part even. So B is a little different. So if you are not at all from physics background, you can see that the dots inside that diagram is less. Okay, it is halfway through. Okay, so let's refer to B, part B we are referring to. So if the control grid is placed at some negative potential, and here it is given as -5, this is with respect to the cathode, and you can see it clearly in this particular figure. It is repelling, or it has repelling effect on the electrons that are actually flowing towards the plate. So what happens as a result of which, this, so consequently fewer electrons reach the plate, thereby reducing the plate current. So it may be added that due to the advantageous position of control grid, the reduction in plate current, so the reduction in plate current is much more than could be by some larger plate potential. And this is very well portrayed in the B diagram, marked as B. Now we move on to the part C. So let me erase all this. So part C, again the diagram is different and the voltage has increased, if you can see. So we will actually have a look on why it is happening. So just let me pause it and I'll erase it and come back to you. Now, as the negative potential on the grid, called the grid bias, is increased actually, the plate current decreases continuously. If the sufficient negative voltage, and it is given here, if you refer the diagram marked as C, it is minus 20 voltage, is placed on the grid. So placed on the grid, then the plate current actually becomes 0 and the triode is said to be cut off. Thus, the important thing that you should note here is that the smallest negative grid voltage for a given plate voltage at which plate current becomes 0 is known as the grid cutoff or cutoff biases or cutoff bias, any of the two. Next we move on to the part D, which is the last part, and after explaining you this we will actually wind up today's tutorial. Now we talk about part D. So if the control grid is made just slightly positive, say given by plus 1 volt with respect to cathode, as it is demonstrated here, the helping electrostatic fields of plate and grid will actually accelerate the electrons towards the plate. As a result of which what happens is that the plate current is increased, and at the same time some of the electrons are attracted to grid to constitute grid current. So the grid is undesirable. Now you must be thinking why this particular word I have used, or this term has been used. It is because it is causing, or it causes, power loss. This is the key term which you should remember in the grid circuit. So just I'll ask you to pause the video and think, as a result of this what happens, or what this analysis, what should be the result of this analysis. It is that therefore grid is always kept at negative potential with respect to cathode, or otherwise there will be the situation of power loss if you keep it at, if you made it even slightly positive with respect to cathode. So this is all about you should know with regard to vacuum triode, its construction and the working. Now in the next class we will talk about characteristics of triode valve.